Welcome to Chapter 3, Section 1, Exponential Functions and Their Graphs. Describe the graph as a transformation of the graph f of x equals 4 to the x power. Well, in g of x, we've got 4 to the x minus 2, which tells us since the minus 2 is with the x, it's a horizontal shift right 2. In h of x, we have negative 1/2 in parentheses 4 to the x power. The negative tells us there's a reflection over the x-axis, and the 1/2 gives us a vertical compression of 1/2. Now looking at q of x, we have 4 raised to the negative x plus 3. Since the negative is with the x, that gives us a reflection over the y-axis. And the plus 3 gives us a vertical shift up 3. Next, we're going to look to see how we sketch exponential graphs. We've got f of x equals 3 to the x power. Well, when we put negative 2 in, that gives us 1/9. When we put negative 1 in, that gives us 1/3. When we put 0 in, that gives us 1. And when I put 1 in, that gives me 3, and 2 gives me 9. We have a nice exponential curve that increases rapidly after it passes the y-axis. And it has a y-intercept of 1. The difference between f of x is equal to 5 raised to the x power and f of x equals 3 to the x power is the speed at which our exponential increases after it passes the y-axis. And again, notice that our y-intercept is at 1. So negative 2 gives me 1/25, negative 1 gives me 1/5, 0 gives me 1, 1 gives me 5, and 2 gives me 25. And we see that the rapid increase after it crosses the y-axis. Now let's look at the reflections of those two problems. Well, if I put in negative 2, that's going to give me 9, because that's going to be a negative 2, which means positive 2. And I see all that's happened is that my numbers for my y's have reversed from what they were on f of x equals 3 to the x. That means that I am decreasing rapidly before I get to the y-axis, and my y-intercept again is 1, and then I level out. Same thing with f of x equals 5 to the negative x. I decrease rapidly, and of course this one decreases more rapidly than the previous one. And again, I go through the y-intercept of 1. Next, we want to solve our exponentials. Well, to be able to solve, our bases of our exponents of our problems must be both the same. As we can see in our problem, we have 16 equals 2 to the x plus 2. So I need to write 16 in terms of a base 2. Well, that's 2 to the 4th power is equal to 2 to the x plus 2. Now our one-to-one property then says I can set the 4 equal to the x plus 2. Because they have the same base, that means the exponents must be equal. Well, I simply solve my algebra problem, subtracting 2 from both sides, and I find out x equals 2. Okay? Moving on to the next one, I see 1/3 to the x power is equal to 1/8. Well, I know that I can write 81 in terms of 1/3. It's just going to be a negative exponent. So I've got 1/3 raised to the x power is equal to 1/3 raised to the negative 4 power. Because 3 to the 4th power would be 81, so 1/3 to the negative 1/4 power would be 81. Now that my bases are alike, I can now set my exponents equal to each other. So that means that x equals negative 4. And that's Chapter 3, Section 1 all together. Thank you. Bye.